So hello everyone, this is Dr. Nitin Sharma, IT department from Akgec Engineering College. Today I'm going to discuss about a Pandas data frame. It is a library in Python which is used for data manipulation and analysis tool using powerful data structures, right? So let me start with the first step. So if you want to use a Python pandas in Python, so first of all you have to install this package. So in Anaconda, you can just write this command, that is conda install pandas, or either you can use a pip command in a Jupyter notebook. So for the Jupyter notebook, user can use run this cell, that is pip install pandas. So with the help of this pip install pandas, the panda is installed in a Jupyter notebook. Okay, so after that you can use it. So before you want to use a pandas data frame, you have to import this package. So that is import pandas as PD. So that pandas import pandas, that means you are imported that pandas package into your current library current file. And as PD is just a alias name. You can write any other name which you want to write. So whenever you need to be call any function from the pandas library, you can call with the help of this PD. Is the shortest name, so you can use directly write it PD dot whatever function you want to call it. Okay, next. So before understanding how you can work on a data frame, so first of all you have to be understand what is data frame. So data frame is just like a table. You can see this is a data frame which is having a number of rows and columns. So you can see these are the rows and these are the columns, right? And this one is basically the column indexing, and this one is basically row indexing, and this one is basically the column indexing. So if you want to access any column, you have to be accessed through this column, right? And if you want to access any row, so you can access the row by using this particular index value. Okay, so this is the way the data frame is organized. Okay, so if you want to work on a particular data frame, so data frame is just like a table which is having a number of rows and columns. Got it? So in the pandas data frame, there are two major components there, that is series and data frame. So series is basically a single column. So like series is essentially a column. So a single column, if you are having a single column, that is basically you can use a series. And what is data frame? Data frame is a multi-dimensional table made up of a collection of series. Like number of columns are connected. Suppose we are having here first column, second column, third column. Okay, so this column is having a multiple values like this way. Okay, so there are three series. If I can collect all of them, so it is basically make a data frame, right? A data frame which is having a 3 column and 4 rows. So data frame, we can also say that it is a collection of series, or either we can say that in a data frame is basically in a tabular form. Okay, so data frame and series are quite similar in that many operation, right? Obviously, if you are applying any operation on a single column, so you can apply on a multiple operations. Okay, so you can do multiple operations like filling the null values, calculating the means, mode, many more statistical operations you can apply on a data frame. Okay, a data frame is a two-dimensional data structure. Data is aligned in a tabular fashion in a row and column. As I already told you that data is organized in a row and columns. Is we can say that in a pandas data frame we can handle through the data frames. Okay, what are the features of data frame? So potentially columns are different types. So like if I'm talking about a data set, so if data set is having a multiple columns, so multiple type of data is there. So suppose this is having a integer type data, this is having a string type data, this is having a float type data. So multiple data types data you can collect into a single data frame. Okay, and the size is mutable. Label access, obviously there are indexing are there, row and column are indexes are there, so you can access through the column or either the rows values, and can perform arithmetic operations on row and column. Obviously, if you want to apply any arithmetic operation, you can easily apply on a pandas data frame. So these are the features in a data frame. So that's why the data frame is basically used for the data manipulation, data analysis, or the majorly basically pandas is used for the data pre-processing. So like if you want to do the data pre-processing means you want to analyze the data, you want to rectify the data, you want to remove the missing value, handle the missing values, outliers. So if you want to do these are all the things, you can use the pandas data frame, right? One more example you can see through this diagram. So you can see this is the series apple, and this is the another series, this is orange. If I can combine together, so this has become a data frame which is having a two columns like apple and orange, and you can see this data is arranged into a tabular form. So two columns are concatenated together and create a data frame. So this is the way you can see the data frame is created by the using of series, right? Okay, so type of data structure in Pandas. So basically there are we have already discussed about the series and data frame, and one more is panel. So panel is basically generally a 3D labels, which is basically a conceptual based array. So the data is basically arranged into the 3 dimensions. Okay, next, Pandas data frame. So first of all, we have to see the main function is there, that is data frame. How you can create a data frame. So Pandas library we are using here. So you can write here Pandas, and the function is calling here the data frames. And these are the options parameters which you can pass here. First is data, second is index, column, dtype, and copy. So first parameter is basically a compulsory. Data is compulsory. You have to pass the data. Index, column, dtype, copy, these are automatically taken by default values. If you don't want to give, so no need to be worry about it. No need to be given the index value or column value. It is automatically taken. If you are giving any kind of values here, it is overwritten. So one by one we can understand what is data, index, column, dtype, and copy. So first is data. So data taken various form, like either you can pass a numpy array, nd array, either you can pass a series, map, list, dictionary, constant, and also another data frame. So you can pass any kind of data here. Suppose you are having a numpy array, some rows and columns. So you can just pass it. You have a list which is having a 2-dimension, 1-dimension, 3 dimensions list. You can just pass it here. It is automatically converted into a Pandas data frame, right? Index. For the row label, they are used for the resulting frame. Optional, it is optional, and default is a empire arrange n. If there is no index is passed here, it is automatically taken column, and the rows indexing is starting from 0 to n number of columns, right? Similarly, you can use here column. For the column label, the optional default value is empire arrange. So it is, if it is only true if no index is passed. If there is no indexing passed, the column is also initialized with 0 column, first column, 2 column, 3 column, this way, right? What is d type? Data type of each column. So whatever data you are passing, it is automatically considered that what kind of data is there, they automatically set the data type, right? And copy is basically the command or whatever it is used to copy of data if the default is false, right? So what kind of data we are passing? We can pass here the list, we can pass the dictionary, we can pass the series, we can pass the numpy array, we can pass the another data frame. I'll take a small example for this. I'll just explain with how you can create a data frame by the using of list. So suppose I am having here a list L1 is equal to 1, 2, 3, okay, and 4, 5, 6. Okay, so this is the list which is having a 2 rows and 3 columns. And if you want to create a data frame from this list, so simply you can write X is equal to PD dot data frame, and you can pass here data. So data is in L1. So when you are going to print here X, so what kind of output is there? Output is just like this. Yeah. 1, 2, 3, 4, 5, 6, and the column indexing is 0, 1, and row indexing is 0, 1, 2. This is the way the data frame is created. Understood? So similarly, just like you are passing here a list, similarly you can pass a dictionary, you can pass a series, you can pass a numpy array. Whatever data you are passing in this function, it is converted into a Pandas data frame. After that, you can use the functions, Pandas functions on particular data frame. Okay. So creating a data frame from scratch. So let us understand how you can create a data frames. So one by one, you can see the example. So first of all, you have to be import the Pandas data frame, that is import Pandas as PD. And in the second line, you can see I am create a dictionary here. Data is equal to, I am writing here the apple, and this is the values. So suppose we are having some students. So apples is first student is having a 3 apple, second student is having a 2 apple. So this kind of data is here. And second is orange and 0372. These are the orange data. And what I have done here in the next line, you can see pd.data frame. I am just passing here the data. So what they are taking here is this dictionary data is converted into a Pandas data frame. And what is automatically done? Automatically is done that these key values is considered as the column indexing, and this is the data which is stored into the Pandas data frame. You can see the output here. If you can see the output, so the column name is apple and orange. As you can see the name of the dictionary, key value of the from the dictionary, and the values are here 3201. So 3201 is copy from this, and 0372 is oranges are here. And because I'm not passing any kind of column indexing, so by default it is taking here 0123. So this is the simplest way you can create a data frame from a dictionary. Okay. Next, how it is work. So another example is that you can see in the previous example, I am just set the data and I'm not setting the row indexing here. Column is already taken the key values, apple and orange. So how you can pass the row indexing here? So row indexing here, another attribute is indexing. I have here, you can see there are 4 rows. So we have passed here 4 row values, right? So Ahmad, Ali, Rashid, Hamza. So these are the 4 names you can see here. So these 4 names are set as a row indexing here. Got my point? So if you want to access any row, so you can call the function that is df.loc. Loc is basically for location. So location, you can pass the location value like Ali. So Ali is having a 2 apple and 3 orange. So you can see here 2 apple and 3 orange. Got it? So if you want to access any column, so column you can write df and the column name like orange. Understood? So if you want to access any column, you can simply write df, then the column name. And if you want to call any rows, so you can write the loc and Ali. Got it? Next, orient. So orient keyword is basically, you can see the first I have created a dictionary, and the from dictionary function here I am using here. So take a data here and convert it into the data frame, as you can see the output here. And in the second one, what I have done here, orient function attribute I am using here is equal to indexing. So whatever indexing here passing, I just want to check as a oriented. Okay. So row 1 and row 2 is not working as a column. It is taking as a row values. Why? Because I am changing here the orientation of the indexing. Got my point? In the second one, you can see orient is equal to indexing, and the indexing you can see here, the column indexing is basically 0, 1, 2, 3. By default is 0, 1, 2, 3. And if you want to set, so you can write here columns is equal to ABCD. Got my point? If you want to set the row indexing, you can use index is equal to, the attribute is index is equal to. If you want to set the column indexing, you can use the column attribute. Got my point? Both are different. Indexing is basically for the row indexing, and column is basically used for the column indexing. Got it? Now another is which is majorly used in the ML project or the data analytics project. You are having a data either in a different formats, like you having a data in a CSV format, Excel format, HTML, HDFS, JSON format, SQL. Many kind of different data set are available in a different formats. So how you can do this? You have to read data from this to the Pandas data frame. You have to do the data analytics and manipulation, and after that you can restore into the CSV file or the same kind of data file. Okay, how we can do this? So one by one we can see here. So this is the smallest example. I have a data set which is having some data. So dataset.csv file. So how you can import it? It is so simple. First you have to import the data. Then after that you can just write pd.read_csv. Read_csv is a function which is used to read the CSV file. Okay, and after that you can just print data frame. When you are using here print data frame, so print data frame is here, and that data is having these column apple and orange. These are the data and these are the column indexing values. Okay, Another thing is dataset underscore CSV index underscore call is equal to 0. Column is equal to 0 means it is just reading from the 0 indexing column is considered as a index values, right? Next, similarly, you can see here we are reading here. So you can understand the index is equal to 0 through this. So when I read this dataset.csv, so data is reading in this form, right? And you can see this is also considered as a column name. This index value is also considered as a column. So this is also considered as a part of data. But this is not a part of data. It is basically a indexing, right? So what I am doing here, I am just passing an index underscore call is equal to 0. So that means the column 0 is considered as an index value. So column 0, that is column 0, is considered as an index. So when it is indexing, so data is look like this. This is the difference, right? Similarly, if you want to read the JSON file, you can just call the function read underscore JSON, and inside this you can pass the JSON file address or the JSON file name here, okay? And you can use, after that, the data is basically reading from the JSON file and is stored into this particular data frame, and after that you can work on it, okay? Similarly, you can read the Excel file, okay? So this is the example for JSON file. You can see this is a JSON file, and as you know that JSON is basically stored data in a dictionary format, right? Or we can say that nested dictionary format, okay? So this is a kind of nested dictionary. So the curly braces is here, and apples is basically store the data. Ahmad is having a 3, Ali is having a 2, Rashid is having a 0, Hamza is having a 1. Similarly, the orange data is given here. So this kind of JSON file you are having here. And what I have done, I have just written pd.read underscore JSON, and I am just reading this dataset.json file and store into the data frame. When I print it, so you can see this is the data frame is printed and all the data is here. So similarly, like you are reading a Excel file, or similarly you can read the JSON file or CSV file, okay? Another file you can see here. So what I have done here, I have also here some attributes. So same kind of data is here, but in a different format, right? So what they are doing, they are just taking these 4 values as a column, and these are value as a rows value. When I read this JSON file, so you can see apple and orange and Amjad, Ali, Rashid, Hamza, these are the data here. Got it? So just like the orient value you are setting here at that particular data set, but here no need, because the data is available into this format. This is also kind of a nested dictionary, right? A dictionary which is having another dictionary, right? Another third example is here. So you can see I'm using here the orient keyword. So when this kind of data is here and I have read, and when I read orient is equal to indexing, so data is here. When I set a orient is equal to column, that is which is having a by default value, so the data set is here. Like in the previous example, you can see in the previous example, this is the way. So this is the way because the orient is equal to column by default value. If I can override orient is equal to indexing, the index value is basically this one. So this one is basically taking as a column, right? Now, next, once the file is read, data is manipulated, and after that, what you have to do? You have to store that data frame into a CSV file. After manipulation, after setting the mean value, mode value, or drop the null values, handling the missing values, handling the outliers. After that, you have done a lot of work on that particular data set, and your data set is clean, or data set is perfect to apply into a machine learning model. So what you have to do? You have to be stored into a CSV file or a JSON file. So what you have to do? You have to call this to_CSV, to_JSON. So whatever data frame you are working on it, that data frame is basically stored into a new CSV file after the processing of that particular data set, right? So you just understand one thing through this one. So this is the file I am reading into a data frame, pre-process, manipulation, data visualization, whatever we want to be done. we have to do in this particular data frame. When the work is done, the data frame is ready. When that means data is ready, that particular data frame is stored into a CSV file. So when you want to be read, you can call a read underscore CSV, right? And when you want to store this into to underscore CSV, right? These are the two functions which you can use here. Okay, so read underscore CSV, and if you want to store, so to underscore CSV or to underscore JSON file. Okay. Most important data frame operations are, so data frame possesses 100 of methods. A lot of methods are available. So for the loading data set, you can use a read underscore CSV file. Okay, so this is the way you can use here. The some operations are there which you can use. First is head. Okay, head function basically which is used to show the top 5 rows. Okay, it is our print out the few rows, not it is basically top 5 rows. If you want to see the more rows, so you can use pass a number here like 10, 15, 10, 8, 9, 5, 2, whatever number you are passing here, it is basically shown here. Tail is basically the accept number, which in case we print the bottom 2 rows. Okay, if you are passing here 2, it is printing the bottom 2 rows, or 10, so bottom 10 rows. So head is basically printing the top and tail is printing the bottom rows. Understood? Next function is info. Info is a function which is basically giving the information about your data. So when you are calling this function, the output is here, and you can see in this output, you can see total how many number of entries here, total columns here. Here you can see the column names. Here how many null values are there. Okay, so in this example, you can see we are having 1000 entry, but 872 is non-null values. That means 138 values are null here, right? Another is the data type. So you can see integer, object, integer, float. So data types is given here, and the summary is here. Data type, there are 3 float values, 4 type of data, 4 column is having an integer type, and 4 is having a object type. Okay, how much memory they are using? Memory is basically using 93.8 plus KB data, right? Another function is shape. So shape is giving how many number of rows and columns. So 1000 rows and 11 columns are there. Okay, so this is the way you can just get the information about your data. Next is your drop duplicate value. So like if you want to drop the duplicate values in your data set, so you can call here the drop underscore duplicate function. One more attribute is here, that is in place is equal to true. By default value, so in place is equal to false. So when you are calling without this in place attribute, when you are calling this drop underscore duplicate, it is basically drop the duplicate value and show you the data, right? But that not drop the duplicate values from the original places, right, where the memory is basically taking that data. So what you have to do, you have to be call here in place is equal to true. After this, they drop the duplicate value from the that particular store values, right? So this is very important when we are working on it. Sometimes we forget about the in place is equal to true. We drop the duplicate values, and after that we can see there is no duplicate values drop from the original data frame. So what we have to do, so you have to do the in place is equal to true here, right? Now describe. Describe is a function which is basically giving the statistical information about the data set, right? And it is only give the statistical information about the integer or float type data type columns, right? If there is a column which is having an object type, so they are not giving that kind of describe information. Why? Because it is giving only the statistical information. So statistical information you get from the only from the numerical type values like a integer or float, right? So you can see it is giving describe function is giving some statistical information. So count how many records are there, what are the mean values, what is the standard deviation, what is the minimum value, what is the maximum value, 25 percentile, 50 percentile, 75 percentile, right? This kind of things are shown here. Okay, what we are getting information from this kind of data, right? So I'll give you some insight information from this. So whenever you are checking this describe, so what are the things you have to be observed here? you have to be observed here. The 50 percentile value must be nearby or equal to, the mean values. So you can see here, these are the equal. This is a nearby. This is also a nearby, right? 6.7 to 6.8. This is also a nearby value. So that means my data is correct. Another things you can see also here. Suppose I am talking about this year or a runtime. Okay. And another is rank. So you can see the minimum value. Rank minimum is 1. Year 2006. Runtime is 66. Sometime it may be negative. So year cannot be negative. Runtime cannot be negative. Rank cannot be negative. Understand my point? So sometimes there is a negative value in the minimum portion. What basically the problem is that whenever it is having a minimum value is a negative, that means your data is a inefficient values, right? So you have to be improve that, right? Another example, this is the list. You can create a data frame from the list. This is a dictionary. Second one is dictionary. Another example you can also see is a list is having a dictionary, right? Another example you can see here, I am creating a list of dictionary. I'm creating a dictionary from this, passing the indexing value, column values. These are the another more example you can implement it by using a different kind of data, right? Another example you can see here, this data frame is having a multiple columns and rows here. Okay, so these two data frames I am writing here, reindexing the data frame. So you can use these examples are also implemented. Okay, these are the references you can just use and read and study or practice for more about the pandas. Thank you so much.